Good afternoon, everyone. Today we're going to look at a data set of 4, 7, 9, 1, and 2, a fairly small data set, and we're going to draw a box plot for the data box and a whisker plot for the data using the median, lower, and upper quartiles, Q1 and Q3. Then we're going to look at the percentage of data that lies above 7.5. You'll see why I used that value in just a moment. And finally, we'll look at the standard deviation, the square root of its variance, sigma. Okay. So first things first, if we want the median and the lower and upper quartiles, let's write our data points in order from least to greatest. So that'll be 1, 2, 4, 7, and 9. Now, this is an odd number of data points, so we can get the median right away as the center data point, the central data point. So our median is 4. Now, for Q1 and Q3, the lower and upper quartiles, we're going to have to get the average of the first two data points and then the average of the last two data points. So Q1 will be 1 plus 2 divided by 2, which is 3 over 2, which is 1.5. And the upper quartile, Q3, will be 7 plus 9, right? Getting the average, we add up the 2 points and divide by 2. So we have 16 over 2, which is 8. So now if we want a box and a whisker plot, we also need just to acknowledge that we have a minimum value of 1 and we have a maximum value of 9, right? That will be the ends of the whiskers on the box plot. So I always like to start with the median. Our median is at 4. Then from the median, we can go either way. Let's start with Q1. Our Q1 value, our lower quartile value, is 1.5. So we will make that around here, 1.5. And on the upper side, we have 8. So a bit further out on the right side, over 8, right? 2.5 units, 4 units, something like that. And now we draw from the boxes, whiskers out until we reach the maximum value on the right side and the minimum value on the left side. So we're going to draw an arrow from 8 over to 9, our maximum value, right? And similarly, we'll draw a small arrow from 1.5 over to 1, our minimum value. So here is our box plot for the data set that we have today. Now, again, the reason we use box and whisker plots is because it's a nice way of showing how the data is distributed between the minimum and the maximum value. Once in a while we can have outliers, right? But in this case, none of our data values fit the definition of an outlier, so we don't have to worry about that. Now, all of our data is sandwiched between the values 1 and 9, the minimum value and the maximum value. And so the median tells us where 50% of the data is split, right? 50% is below value 4 and 50% is above a value of 4, right? Now, when we have such a small data set, like 5 data points, right? These percentages can get a little bit wonky. And the reason I wanted to look at 7.5 is because 7.5 is just below the Q3 value, right? The upper quartile. And so what it should mean is that the upper quartile should tell us where 75% of the data falls below. Or in other words, where 25% of the data falls above, right? But in this case, I just wanted to show how it works when we have such a small number of data points. We know just by looking at our data set how many values are above 7.5, right? We have only one of them, right? And one data point out of 5 is, of course, 20% of the data, right? But typically, we have 25% of our data after Q3, right? Q3, and then 25% after. And then for usually Q1 means 25% below, right? And then the median, we have 50% above and 50% below, right? That's typically how it works. But again, just be mindful of these numbers. They're typically pretty great approximations, but when the data has so few values, you know, those numbers can be a little bit off, okay? So what percent of the data lies above 7.5? It usually would be more around 25%, but in this case, we know that it's exactly 20%, 1 out of 5, okay? Now the last part, find standard deviation. Now you can use technology, of course, there are so many different ways to use technology to find standard deviation, but again, we have such a small data set, let's actually do this by hand. So what we have here is, if we want the standard deviation sigma, that is the square root of the sum from I equals 1 to just 5, because we only have 5 data points, right, of the square of the differences, so xi minus the mean x bar, right? Or I guess we should maybe use the population mean in more general terms, right? Not usually something we have to worry about too much. And divided by 5, right? Since we have 5 data points. And this is not going to be too tough. We can do this by hand on the side. So let's find the differences between each data point and the mean, and then we'll sum those all up. So first of all, our mean is the sum of our data points divided by 5, since we have 5 data points. So our mean is going to be, what is that? 11, 20, 23 divided by 5. And so our mean is 4.6, right? So that means that we're going to look at the difference between every data point and the mean of 4.6. We're going to square those differences, sum those all up, divide them by 5, and take the square root. It sounds like a lot of steps, but it really doesn't take too long. Let's go ahead and do that over here. So for the first one, we have 4 minus 4.6, and we know we're going to square that. So that's negative 0.6 squared, so that is 0.36. Next we have 2. We have 2 minus 4.6, all squared. That's negative 2.6 squared, which is, that is 6.76. Next we have 4. Wow. I was looking, not doing it in this order. Let's look at 1 next. We have 1 minus 4.6 all squared. And that's negative 3.6 all squared, right? So that's 12.96. That's a little ways away. Oh, I see what I was doing. I was looking at this list instead of the ones in order. We're gonna catch all 5 anyways. So we've done 1, 2, and 4. Let's do 7 and 9. So 7 minus 4.6 all squared. That is 2.4 squared, which is 5.76. And the last data point, 9 minus 4.6 all squared. That is 4.4 all squared. I'm gonna need a calculator for that one. 4.4 squared is 19.36. So we want the sum of all of those square differences. So let's sum those all up. That, you use a calculator for this, I know I will. 0.36 plus 6.76 plus 12.96 plus 5.76 plus 19.36 is 45.2. So we have 45.2 for the sum of the square differences, and divided by 5. And so sigma, our standard deviation, is the square root of 45.2 divided by 5. That's just a little over 9, right? That'll be 9.04. And the square root of that, very, very close to 3, right? Square root of 9 is 3, so sigma, we'll say, is around 3. Okay, so standard deviation of 3. And there we have it. So I guess we could say that we have one data point that's right around 2 standard deviations above the mean, which is uncommon, but we do see quite a bit of variation from the mean in this data set, right? We have 1, we have a 9, both fairly distant from the mean, and so we should expect to have a decent sized standard deviation because the variation is significant. Okay, so all in all, I hope this helps. These are a lot of things put into one, but again, I hope this was a nice summary of statistics. Thank you for watching, and let me know if there's anything else I can clarify on. Have a great day.